All right, everybody, let's continue talking about Chapter 3. This time, let's specifically focus on data graphics that are in the media. And what we'll do is we'll look at some graphics that are pretty commonly used and some that are not so commonly used. One thing that's really neat nowadays, everything's always changing, even in the field of statistics and how statistical information is shared with others. Nowadays, it seems to me, based on how I was originally taught, that there are almost like no rules. Some of these infographics nowadays that are also called pictographs, they're really just embellished visual displays of information, but they're great, and they're just completely breaking all the rules that used to exist. Here's an example of an infographic describing what an infographic is. And it's just showing that it's essentially taking data and these little pieces of I can't remember what they call these, Legos, I guess, are just representing the data. And then in an infographic, you somehow sort that data. They've sorted all of the Legos. They've arranged them. So, again, what is basic descriptive statistics all about? Summarizing, organizing our data, and then presenting the data so that people can easily understand. And let me give you another example, because some of them can be really annoying, but some of them can be really awesome too. So take a look at this. This comes from a website called Cool Infographics, and they're constantly adding really neat infographics to the site. And I always like this one. It's about American sugar consumption. And first of all, you'll notice throughout, you see a reddish color in much of what they show. And they're essentially using the same color that is used in a Coke can. It's very visually pleasing. It's just awesome, in my opinion. It's a great way to do share data. So this is looking at how much sugar people are taking in. And you can see that it's the visuals, it's the graphics that is telling the story of the data. Here's an estimate of what it would look like with 130 pounds of sugar. So Americans consume about that much every year. And then you can see here that we're using Coke cans, little symbols, to represent the amount of sugar that people consume. So the average American consumed 45 grams of sugar, the amount found in one can of Coke, in 1822. Sorry about that. Now in 2012, we now consume many more cans every 5 days. There's been a huge change. Now, sometimes I think just like how I had a kind of hiccup for a second there, and I wasn't sure what was going on. That is one problem with these infographics. They often have kind of too much information, and a lot of people probably are confused by what they see, or it just takes a little bit too much to understand it. But some of this harken backs to what we've talked about before. This is showing sugar consumption in pounds, so we can see that this y-axis is labeled. Here's our x-axis. It's showing the sugar consumption over these years. This is essentially just a line graph, just like we learned about before, using the sugar. This is talking about the average American consumes 3 pounds of sugar each week. Oh my God. 3,550 pounds in an entire lifetime. It shows how many Skittles that is, and the amount of sugar would fill a dumpster. So they show a dumpster. I mean, you get my point. This, I think, is really neat too. Again, if we're measuring something by teaspoons, they're showing the measurement in teaspoons. So it's just very visually pleasing. 53 gallons of soft drinks per year the average American is drinking, and we're showing gallons essentially of milk. This, I didn't even understand at first. I didn't understand what was coming out of the person's mouth. In the American diet, 500 calories every day comes from added sugar alone. That's the caloric equivalent of 10 strips of bacon. So I guess these are strips of bacon. This is kind of neat at the end. It's just showing that sugar, it says, is as addictive as cocaine. And it's showing the same graphic because they are so similarly looking. I'd have to look up more information to see if that's really a fair comparison. But you get my point. So there are a lot of great ways to display data in the media, and let's talk about some of them in a little bit more detail. Let's talk about multiple bar graphs and multiple line charts. what they have is really 2 or more sets of data within a graph so that we can compare that data. So here's a good example. This comes from Consumer Reports, or Zillions, which I think is Consumer Reports magazine for kids. And it's showing the median weekly income from parents by age for these kids. So, where are kids getting this money? Well, you can see as their age increases from 9 to 11 to 13, the amount of money that they're getting from chores, handouts, and allowance is increasing. So, they're getting more money. And you can see it's a little bit difficult to tell a difference between the bar for allowance and chores. It looks like this is the one for chores on the right of each grouping. So we can see that the allowance is going up when we look at these different categories, although it stays the same from 11 and 12 to 13 and 14. We can definitely see handouts, just like the extra money that these kids are getting from their parents is increasing over those ages. And then the amount of money that they're getting from chores is increasing as well. So they're doing more work, they're becoming more productive. Bottom line is we had 3 sets of data there, and it's represented in this one graph. So this is a multiple bar graph. Here's another example, PC and online households in the US, and it's showing 2 sets of data. So the blue bars are representing households with PCs, and the reddish bar is representing households that are online, they're connected to the internet. This is showing in millions the number of households between these years, and we can see these particular years listed. So clearly there's an increase in both categories. The households with PCs is increasing, but not increasing as quickly as households that are going online. Now check this out, we can take that same data and present it as a line graph. And I think this helps show that data a little bit better, show that the online households are kind of increasing quicker than the households with PCs, because now we can see this line is heading up at a quicker rate than this one is. And in fact, if we were to extend these into the future, what I think we'd probably see is something like where this one's really heading up, and this one will start to level off and maybe even kind of start to head down, because PCs aren't something that you need anymore necessarily to get online. People get online with their phones, people have things like iPads and other devices. And that's interesting because that tells me something potentially about the data in the future. What I predict, I've predicted this for a while now, is that people are going to have poorer computer skills over time. A lot of people, probably a lot of people in our own class, grew up using computers. And like when I was in college and graduate school, I was very intensively, heavy using computers, and I learned to really like it. So I'm very computer savvy, and many of you probably are too. But younger people are not. Younger people are not really very good at using computers, not because it says anything about their intelligence, but it's because they don't spend much time using computers. They're using their phone, or they're using an iPad, something like that. So that could have some effect on, something in the future. Now again, that issue comes up, which is right? Should we be using a multiple bar graph or a multiple line chart? And again, it's up to you. Which tells the story of the data better? I like this one better. Let's talk a little bit about stack plots. Stack plots are essentially just vertical stacks that display our data. Some of them are pretty easy to read, like this one. It's showing the population percentage for a variety of different people categorized by their race for various years. And here it's just very easy to see. If we are projecting out to 2050, we can see that white Americans are still making up the majority, but not nearly the way they did like in 1990, for example. We can see that Hispanic Americans are growing in population, as are Black Americans and other. Very, very easy to read this. But now check out this one. This one's not quite as easy to read, although it does provide quite a bit of information. It says death rates for various diseases from 1900 to 2004. So it's like over 100 years. We have to look very closely. It shows deaths per 100,000. All right, so 100 deaths per 100,000 and so forth. Per 100,000 people is what that represents over these years. So we can look overall. So in the year 1900, when we look over all of these different diseases. The orange is pneumonia. Here we have cardiovascular diseases. Here we have tuberculosis. Here we have cancers. In 1900, we can see not all that many people were dying of cancers. We had lots of people dying from tuberculosis and cardiovascular diseases and pneumonia. We can see over time this overall trend has headed down. Now remember, the level that we have here in the stack, remember the stack is now incorporating these 4 different diseases. We can see the entire stack is lower in 2000 as compared to 1900. So fewer people are dying per 100,000 based on these 4 diseases. But it gets kind of difficult to look at. We can see here how many people died of tuberculosis, but we have to kind of compute the difference between these numbers. This is 250. Here, this is maybe 75. We would have to do the math there to figure out how big this particular chunk is. Here's an example. It's saying for 1980, the top of the cardiovascular wedge is about 620 along the vertical axis. So right here equals about 620. And then right over here, it says the bottom is at about 180. So if we wanted to compute how many people were dying of cardiovascular diseases in 1980, we need to take 620 and subtract 180. I'm not sure that's something that people really want to do in their graphs, consumers of that information. When I'm looking at a graph in the news media, I don't think I want to be pulling out my calculator and doing that much work. That said, it does a really good job of showing me, look at tuberculosis here. I can see that people were dying, even if I don't want to compute the exact number. And I can see over the years, this wedge has gone to essentially 0. We've essentially eradicated tuberculosis. I can also see here that this wedge for cancer is getting larger. So, people are living longer and, there are changes to our environment and more people are dying of cancer in the year 2000 compared to 1900. I can also see here that pneumonia, although this wedge has gotten smaller, from this point on, you can see that the size of the wedge has remained relatively constant. So we're not necessarily doing a better job of eliminating pneumonia. It's remaining relatively constant, but at least compared to previously, we have it more under control. So it's a very interesting way to display a variety of data, but it's getting somewhat complex. So this is a stack plot. We want to make sure we can understand it. In my sense, in my view, this particular one is a little bit too confusing, but I might be a little bit too critical. As I look at it more and more, I like it more and more, but how many people are going to spend this much time really looking at a display? Let's talk a little bit about geographical data. And as you would expect, geographical data corresponds to geographical locations. Here's a great example. This was taken before an election for president, and it shows the probabilities of who is going to win the upcoming presidential election that we had at that time for looking at Obama versus Romney. And again, it just does this great job of displaying a lot of data. We can easily look at the states just based on where they are in the map, because most of us are familiar with the maps. If we look at Ohio, we can then see by its color, when we look at the scale here, that it represents Obama has somewhere between a 50 and 60% chance of winning. And again, even the colors make sense because you've probably learned from following political discussions that red is always associated with Republicans and blue is always associated with Democrats. So you can see here, Romney is simply going to win Texas. We knew this ahead of time. The probability was very, very high. But Ohio, it was a very close race, although it was leaning toward Obama. So these state-by-state probabilities were able to be expressed to us in this really very easy-to-read geographical map. This is a great website. You should check it out sometime, particularly when presidential elections are coming out. The 538.com website is run by Nate Silver, who is a brilliant statistician. Via his website, he nailed every single state in the last election. So this is why I tell you, smart people make decisions based on the data. A lot of people thought this was going to be a close race, but those of us who are really looking at the data, we knew easily a month out who was very likely to win that election. Let's just close here by looking at combination graphics. Combination graphics put together a variety of different techniques. And this right here is a really good example of how we can pack these graphics full of information. Now, that's a good thing and a bad thing, right? Sometimes I can put too much information in a graphic. This one has a lot, but it seems like it's easy enough to pick it apart. It's looking at the ever-growing presence of women in the Summer Olympics. So this wedge right here, this little pie chart, is showing the percentage of women who are participants. Back in 1900, we can see the wedge is very small. And the numbers are listed too, so it's easier to help us identify the actual value. 1.6% of the participants were women. And we can see that number stayed really low until maybe around 48, and then it started to take off. And we can see that wedge is getting bigger and bigger and bigger. Well, we can also see those wedges are tied together with this line. So in here we also have a little bit of a line chart going. And this line coincides with these values in here. That's the actual number of women participating. So for example, in 1984, the line is about right here. I'm looking at the red line. That coincides to about 1,500 women. But in 04, our line is way up here. We can see that about 5,000 women were participating. And there's still even more information. We can see for each year, we have more data right below it. That's representing the number of events for women. So back in 1900, there were only 3 events for women, but in 04, there were 135 events for women. So there's tons of information in this one graphic. So we'd call that a combination graphic because many different techniques are being used. So I just wanted to introduce you to some of the more common and also less common graphics that are often used in the media. That's really the key content from section 3.3. For now, that is all.